Year 6, Lesson 8, Extensive Exercise, Question 3. Two overlapping triangles, POR and QOT, are such that points P, Q, R and T lie on the arc of a semicircle of centre O and diameter PQ. Lines QT and PR intersect at point S. Angle TOP is 3x and angle ROQ is 5x. Calculate RSQ. So we're looking for RSQ, which is this angle marked by the double angle line. Okay. Now, in order to find out that angle, we're going to have to use the two angles we know and see what we can figure out from them. So if I pick the first one, 5x. Now, 5x forms the exterior angle of this triangle here, POR. So let's look at that triangle. Now, the side OP is the radius of this circle because it goes from the centre to the edge. But if you look at OR, that's also the radius because it still goes from the centre to the edge. So therefore, these two sides must be the same as they are both radius or radii. Now, this is a common trick to look out for with these angle questions in circles, because if we have two sides which are the same, then this is an isosceles triangle. So therefore, we have the angle in between them, and then the other two angles must be the same. So we know that OPR and ORP are the same angle, and I've shown that by marking them with a blue angle sign. So now let's figure out what they are. So, using our exterior angle theorem, we can see that ROQ, or 5x, is going to be equal to the sum of the other two angles, which are the same. So that's angle RPO and angle ORP. So those are the other two interior angles. Now, if both of these two angles are the same, then each of those will have to make up half of 5x. So therefore, I can say that each one has a size of 5x over 2. Okay? And we get our missing angle. So why don't I label one of them just to remind us? And we have RPO equals to 5x over 2. Okay, we're one step closer. So now let's rub out what we've done already and just fill in those two angles that we've just learnt, which is 5x over 2. Okay, so next we'll have a look at the 3x. So the 3x forms the exterior angle of this triangle here, OTQ. So in a very similar way, in fact exactly the same as before, OQ forms a radius and so does OT. So what do we know when we have two sides which are the same? We know this is an isosceles triangle, and therefore OTQ and OQT, the two base angles must be the same, as I've marked with the red angle line. So now we have a look at the 3x, which is the exterior angle of this triangle, formed from extending that line to create an angle. So in a similar way to before, we can see that that 3x is going to be equal to the sum of OTQ plus the sum of OQT. So both of those angles, which again are to be the same, must both be 3x over 2. And we can see that, let's label one of them, we'll label OQT is equal to 3x over 2. Okie dokie. So now let's rub out some of this labelling, and I can label the two new angles, which are 3x over 2 degrees and 3x over 2. So if we now take a look at the required angle, RSQ, so I can see that that angle forms the exterior angle of this triangle, which I'll label in blue. So there's the third triangle, which we haven't used yet. So this triangle, we know RSQ is the exterior angle. So therefore, RSQ is going to be equal to the sum of the other two interior angles, which now we know. So that's going to be equal to the sum of RPO, or let's say RPQ, plus angle PQT. See? So both of those angles we know, so we just add them together and we get 5x over 2 plus 3x over 2, which is going to be equal to 8x over 2, or 4x, most simplified. And we're finished.